Bismillahirrahmanirrahim. Today we will discuss about the water conditioning for municipal purposes. Water coming from the underground or from canal or river, it may contain a significant amount of suspended particles and many pathogenic organisms. So to make this water palatable or to be used in municipal uh, purposes, to used for the municipal purposes, this water should be treated, should be purified by performing different water conditioning and different water purification processes. In this lecture we will discuss these processes through which we can treat, we can purify the water coming from different sources. Water is a transparent fluid which contains slightly charged water molecule on its both ends. Oxygen being electronegative, it carries partial negative charge. However, hydrogen is carrying partial positive charge. So this water can exist in three physical states: liquid, solid, and gaseous. While in the form of liquid, it's a universal solvent, and it is very essential for many forms of lives on Earth. When the temperature of this water molecules gets lowered, then these water molecules in the liquid form will be transformed into the ice in the solid form, and it will float on the surface of water. And after getting some suitable energy from any source or by colliding among each other, some molecules excited and go into the vapor state. There will be another form of water, which is a steam. So water covers almost 71% of Earth's surface, and its density is 999.97 kilogram per meter cube. Its boiling point is 100 degree, and molar mass is 18.0. Pure water is tasteless and odorless. However, the presence of some different substances giving it some taste and odors. Pure water contains no minerals and no other substances. When these minerals are added into the pure water, these minerals impart some characteristic taste and odor to the water. When these minerals are in excessive amount, then the water can be named as dirty water or hard water, and depending upon the type and minerals of present in the water. So this water is very essential for the life on the earth. Metabolism is the sum of total of anabolism and catabolism. In anabolism, water is removed from the molecules through energy requiring enzymatic chemical reactions in order to grow larger molecules. For example, the formation of starch molecules, triglycerides, and protein for the storage of fuels and information. In catabolism, water is used to break bond in order to generate smaller molecule. For example, formation of glucose, fatty acid, amino acid to be used for fuel, for the energy use, or other purposes. Without water, these particular metabolic processes could not exist. Water cycle gives you important information about the transformation of water from one physical state to another physical state. We have a few sources of water. However, we have plenty of reservoir on the earth crust, on the earth planet. These reservoirs includes the glaciers, the spring, the freshwater bodies, the rivers, canals, and in the form of vapors. These are all the reservoirs. So when the water melts on the top of the hills on the glacier, the water comes down, and it will it will form some springs, some freshwater body storage, and this liquid form which is coming from the ice after melting, these liquid form can be found in the canals, in the rivers, in the oceans. And when these water molecules get some energy from any source, from the sunlight or from any other uh, heat source, these water molecule gets excited and goes into the vapor state, and these vapors can come on the earth after the condensation process. So this is the total water cycle. You can see here in this photograph, the water comes from the ice and snow to the earth, and it will again transform into the vapors, and from vapors it will comes down in the form of rain on the planet, on the hills and the earth crust. Water conditioning is a procedure to remove contaminants from the groundwater or any other household water. It includes physical, chemical, biological processed to remove physical, chemical, and biological contaminants from the contaminant water. These contaminants can be of various types. It may be in the form of some chemicals, it may be in the form of some physical debris, and it may be in the form of some biological contaminants, for example viruses, bacteria, fungi. So these are all the water contaminants. So our goal is to produce, by using this water conditioning process, is to produce water which is safe and fit for specific purposes, including human consumption, I mean to drink the water, and some medical uses, pharmacological, chemical, and industrial application. Groundwater is a reservoir of water which is emerging from some deep groundwater. It may have fallen as rain many tens, hundred, or thousand of years ago. Soil and rock layers naturally filter the groundwater to a high degree of clarity. Upland lakes and reservoirs, the headwater of river systems, upland reservoirs, bacteria and pathogen levels are usually low in that reservoir. Some bacteria, protozoa, and algae may exist in these upland and reservoir. Where upland are forested, humic acid can color the water. Many upland sources may have low pH which requires its adjustment. Rivers, canals, and lowland reservoir are another form of water reservoir, and these contains lowland surface waters which have a significant bacterial load and may also contain algae, suspended solids, and variety of dissolved constituents. Atmospheric water generation, it can produce high quality drinking water. from the air by cooling the air and thus condensing the water vapors from that trapped air. Surface water, which contains fresh water bodies that are open to the atmosphere and are not designated as groundwater, are termed surface water. This schematic diagram shows the overall process to purify a water. In the first step, water is received and inspected for its uh, physical inspection to check its odor to color, and after that it is processed by activated carbon filtration, and this specific process will be used for municipal water only. Then this sample of water will be pre-treated and demineralized. In demineralized means the minerals present in the water will be removed, and after demineralization this water can be stored in a huge tanks, and then after taking the water from these tanks, these water will be remineralized. I mean, remineralized is a process in which you can add some important minerals which are essential for its application. Then these addition of minerals, this water sample will be microfiltrated, or and this is uh, processed under UV light to disinfect the biological contaminants, and ozone disinfection. This is another way to disinfect the biological contaminants. Then this form of water can be processed for bottling control and the packaging control. So these are the processes which are involved in water conditioning. The first of all, screening, aeration, flocculation, sedimentation, filtration, disinfection, and softening. First of all, we will discuss the first procedure, that is screening. Screening is done to carry out the removal of heavily suspended solids from the water, like plants, stones, animals residue, or trees, leaves, or sticks. These are removed by the process of screening. Screening is generally adopted for the surface water, especially at the intake point. And this screening helps us to remove the floating and the suspended debris by two processes. Number one, coarse screening. Coarse screening is usually adopted for the particles which are in the range of 10 millimeter to 25 millimeter of size. Uh, and the fine screening is usually done for a water which contain suspended particles of the size less than 10 millimeter. तो इसके अंदर स्क्रीनिंग में हम जितने भी बड़े पार्टिकल जिनका साइज़ जो है वो 10 मिलीमीटर से ज़्यादा या 25 मिलीमीटर तक का होगा, और उसे हम कोर्स स्क्रीनिंग कह देते हैं. फाइन स्क्रीनिंग के अंदर 10 मिलीमीटर से जो कम पार्टिकल्स होंगे उनको रिमूव किया जाता है बाय द प्रोसेस ऑफ स्क्रीनिंग. ग्राउंड वाटर एंड सरफेस वाटर contain both dissolved and suspended particles. Coagulation and flocculation are the process which are used to separate the suspended solid particles from the water. Suspended particles vary in source, charge, particle size, shape, and density. These are the parameters which are dependent for the division of suspended particles. Correct applications of coagulation and flocculation depends upon these factors. Suspended solids in water have a negative charge, and since they have the same type of surface charge, they repel each other when they come close together. Therefore, suspended solids will remain in the suspension and will not be clumped together and settle out of the water unless proper coagulation and flocculation is used. So the coagulation and flocculation occurs in the successive steps, allowing the particles collision and growth of floc. This is then followed by the process of sedimentation. If the coagulation is incomplete, then flocculation step will be unsuccessful, and if the flocculation is incomplete, sedimentation will be unsuccessful. So the flocculation is the process in which colloids come out of the suspension in the form of flake, either spontaneously or due to the addition of clarifying agent. While the coagulation involves the interaction of coagulant chemicals with the charge opposite those of suspended particles are in this process, coagulants are added to the water to neutralize the negative charge on the non-settleable solids. So these coagulation and flocculation are important processes in water treatment, with coagulation to destabilize particles which ranges from 1 nanometer to 1 micron through chemical reaction between coagulant and the colloids. And the flocculation is a process is there to transport the destabilized particle that will cause collision with the floc. So addition of aluminum or iron salts and organic polymer provides high concentration of counterion that neutralize negative surface charges of particles, reduces electrostatic repulsive interaction forces, and net interaction energy becomes attractive, which are mainly van der Waals forces. In this process of flocculation and coagulation, net attractive forces led to the aggregation and settling of aggregates or floc formation. In this picture, you can see there are two form of solution. One is a dilute solution which has a low ionic strength, and when we add the coagulants or the flocculating agent, these ions become closer to each other and form a floc. These molecules get destabilized by the coagulating agent, and after adding the flocculating agent, these destabilized molecules will react each other and form a flakes. These flakes can easily be removed from the water body. Coagulation is a process of addition of coagulant to destabilize a stable charged particle. However, during the process of flocculation, gentle mixing accelerates the rate of particle collision, and the destabilized particles are further aggregated and meshed into larger precipitates. You can see in this photograph, when the solution is in dilute form, the ions which are of the same charge, they repel each other and are in the low concentration, and they are far apart from each other. When the coagulant is added to the solution, the role of coagulant is to neutralize the charges of the particle present uh, in the dirty water. These charges are brought close together, and when they are come close together, they are in the form of floc, and these floc will be removed during the process of flocculation. Aeration is a process which brings water and air in close contact in order to remove dissolved gases such as carbon dioxide, and oxidizes dissolved metal such as iron, hydrogen sulfide, and volatile organic chemicals. So aeration is often the first major process in the treatment of water. During aeration, constituents are removed or modified before they can interfere with the treatment process. Aeration is done for the anoxic water, and usually it is used to remove the unwanted organic matter present in the dirty water. So aeration brings water and air in close contact by exposing drops or thin sheets of water to the air, and by introducing small bubbles of air and letting them rise through the water. The scrubbing process caused by the turbulence of aeration physically removes dissolved gases from the solution and allows them to escape into the surrounding air. The process of filtration involves the removal of flocculated particles of smaller size and those particles that cannot be removed by settling. So this filtration process can involve various filters such as a rapid sand filter, which has high throughput. However, slow sand filters will be exhibiting and lower throughput. Adsorption is another important mechanism for the removal of suspended particles. Backwashing of the filters is very important to regain head losses due to the clogging. And if we are not interested in the backwashing of filters, the filters will be clogged, and the process of filtration will be slowed down. So in order to enhance and in order to accelerate the process of filtration and to remove the maximum concentration of the suspended particles, the backwashing of the filters is very important and essential for the filtration process. Generally, the chlorinated water is used to backwash the filters, and this chlorinated water is often used to disinfect the filters used in the filtration process. The dirty water, uh, which may have a significant amount of some pathogens, which may be of biological pathogens, which may be of chemical pathogens. So in order to remove these pathogens, the process of disinfection is carried out in the water treatment. In the first step, the pathogens, biological pathogens, will be removed, and these pathogens will be destructed by the process of sterilization. This process of sterilization can remove almost all forms of pathogens, biological pathogens such as microbes, which may be viral or maybe bacteria, and fungal spores can be neutralized, cysts and viruses. In this process of sterilization, autoclave machines are used, and in autoclave machines, about 100 plus about 121 degrees Celsius is applied at with varying pressure. In sterilization process, you can also use some membrane. In this membrane, the microbes of micron sizes can be stopped to be passed from this filter, and resultantly the water which we are getting is free of the biological pathogens. There are some physical methods which include the membrane filtration and radiations, introduction of the radiation. You can use the UV radiation, ultraviolet radiation, which are of higher energy and lower wavelengths. When they are irradiated, the sample may contain some pathogens. These pathogens can be killed by the introduction of ultraviolet lights. Similarly, we can use X-rays light and gamma rays, which are more energetic light as compared to UV light. So these are more beneficial to kill the pathogens present in the biological pathogens present in the water. So some other methods, which are chemical methods, are used to disinfect the water, such as chlorinated compound, chlorine or chloramine. Ozone can be used to disinfect the water, and similarly potassium permanganate is also being used to disinfect the water. Among other methods which are used for the disinfection, chlorine is one of the potential method to be used for the treatment of water. It is number one, it is a potential germicide. It can kill almost all the germs present in the water due to its high oxidation potential, and its residual in the distribution system. It can be present after the treatment of water. So chloramine can also be used, but this chloramine is of lower potential to be used as oxidation potential. The second important parameter, which is taste and odor control. This chlorine disinfectant is usually used to control the taste and odor. Oxidation and removal of compound causing taste and odor problems, these compounds can be eliminated by the chlorine disinfectant. Similarly, the biological growth control. The growth of algae and bacteria in the storage reservoir and water supply systems can be inhibited by applying the chlorine in the water sample. So similarly, some chemical control as well is also being an important property of this chlorine. So iron and manganese, if we are interested to remove the iron and manganese, then we can use the chlorine as a disinfectant to remove these chemicals which are not good for cleaning purpose and other applications of water in the routine life. Pure water doesn't have any impurities or any minerals in it. So the water has some taste and odor due to the presence of some minerals in it. When the water comes from the glacier, it passes through the through the mountains, and during its traveling, this water can contain a lot of minerals in it, and the presence of minerals such as cations. If the water contains a monovalent cation, then the level of hardness is a temporary hardness, and if these water samples contain divalent cations such as calcium, magnesium, iron, manganese, then the water may be of permanent hard water. So in order to remove this hardness of water. Softening is a process which is used to remove the hardness of water. So the general acceptance of hardness is 150 milligram per ml according to the recommendation. So when the water is hard, and if we are using hard water, then it can enhance the soap consumption by forming the soap curd in the application. And so by using this hard water, there many other difficulties can be faced. So if we are using this hard water in the boiler to generate the steam, then these boilers can be uh, maybe have some problem with the heating elements, uh, as the ions such as calcium carbonate which are present in the hard water can accumulate, and the heating efficiency of the boiler will be reduced, and overall the efficiency of the boiler will be reduced. So to increase, to accelerate, and to enhance the efficiency of the boiler, this hardness of water must be removed. Here are types of hardness depending upon the presence of constituent of ions in the present in the water. So if the hardness level below 50 ppm, then the type of water is usually known as a soft water. And if the minerals present in the ions present in the water ranges from 50 to 150, then the water is named as moderately hard. And the hard water which contains these cations and anions in the range of 150 to 300 ppm, then the water is known as hard water. And if the constituent is across 300 ppm, then the water is said to be very hard water. So in order to remove the hardness of water, water softener is usually introduced to reduce the water hardness. So if the hard water contains calcium and magnesium ions, then we introduce the sodium or potassium salts to exchange the ions, and in this process the hardness of water will be lowered. Uh, and this takes place within the resin tank of the water softener. Demineralization is a process in which all the minerals are removed from the water sample, and for this demineralization process, membrane processes can be involved, such as electrodialysis or electrodialysis reverse (EDR), or reverse osmosis can also be employed to remove the minerals present in the water. And the second important application is a distillation. You can use a distillation process to remove all the ions present in the to remove all the constituent present in the water. So in the distillation process, water is heated, and during this heating process, water changes its form from liquid phase to and turns into the vapor phase, and the salts which are present in the water will be in the residual water, and in this process the pure water can be obtained. However, distillation and reverse osmosis are the processes which accounts for 87% of the desalination process in the world. So actually reverse osmosis, in this reverse osmosis, the water is passed through the membrane, and all the particles present in the all the minerals present in the water are left behind, and water is just allowed to pass through the membrane. So this process of demineralization removes all the unwanted minerals through the process of reverse osmosis or distillation. So reverse osmosis is a water purification technology that uses a semi-permeable membrane to remove larger particles from the water. In reverse osmosis, an applied pressure is used to overcome the osmotic pressure, a colligative property, and that is a given that is driven by the chemical potential. Reverse osmosis can remove many types of molecules and ions from the solution, including bacteria, and is used in both industrial processes and production of potable water. In this photograph, you can see the process of reverse osmosis. The water is introduced from the left side, and the pressure is applied to the water to just pass from the semi-permeable membrane, and this membrane can stop all the salts present in the water and the contamination, and just allows the water molecules to pass through it, and in this process we can obtain the pure water on the right side of this schematic diagram. In the process of demineralization, almost all the minerals have been removed by the application of reverse osmosis or distillation process. So as the reverse osmosis is not a selective ion removal process, so after the application of reverse osmosis process, the water coming out from it is poor in minerals, and by the consumption of these low mineralized water has a adverse effect such as high corrosion potential of these water. So according to the World Health Organization, 10 milligram of magnesium and 30 milligram per liter of calcium must be present in the drinking water. So in order to enhance the concentration of the essential minerals, the process of remineralization is usually carried out in the water sample, and in this process essential minerals are added in the permissible limit as given by the WHO. After performing all the steps in the water conditioning and water treatment, and the last very important parameter, which is the quality control, every plant is equipped with its own laboratory and quality assurance staff to analyze and ensure all the aspects of the final product of water, which must comply with the standards and the specification of the consumer.